welcome to our pop-up chemistry lab.
I'm Martin.
I'm Lena.
And today we're going to show you some oscillating reactions and other stuff in chemistry.
Whoa!
Gets bigger with time.
This time, especially gloves are very important. For me, because one of the chemicals is toxic, and for what Martin needs, the gloves you will see later. I want to show you a chemical pattern by an oscillating reaction, the Belousov-Zhabotinsky reaction. Normally, a reaction goes into one direction, but oscillating reactions have periodical changes, which we see in our case by the change in color. For the Belousov-Zhabotinsky reaction, we need potassium bromate with sulfuric acid. We add 2 milliliters of malonic acid, and 1 milliliter of potassium bromide. You see there's a reaction. The bromide and the bromate react with the acid to bromine, which we can see by the orange-brown color. And the bromine reacts with the malonic acid. Then when the reaction is complete, the solution is colorless again. And while we are waiting, Martin will prepare his experiments.
So now I will show you some reactions where we need gloves. Usually we put on gloves to for safety reasons that we don't get into contact with the chemicals. This time we will put the chemicals into the gloves. Okay, so I've got 3 gloves here. I labeled them so I don't mix them up later. And for the first glove, I need some magnesia and some citric acid. Into the second glove, I will put some yeast and some peroxide, hydrogen peroxide solution. And into the third glove, I will put some baking powder and again some citric acid. So how do I do that? I just take some magnesia for the first glove and I'll put it into the thumb. Yeah, thumbs up. Thumb is maybe a little bit too much. It's okay. Let's try it out. Worst comes to worst. And then I'll add into another finger, I'll add the citric acid. For reaction to be happening, normally we have to have solutions, liquids. So I'll add into another finger, I'll add some water. I took a little bit too much magnesia, so I'll add more water just to be on the safe side. Okay. Now we have the glove, we have the stuff inside. Now we close it up by making a knot into the back end. This is the hardest part of the experiment. I think this is a knot, pretty sure. And now I shake it for the reaction to start. This is the slowest reaction, but I can already feel it getting hot. Yeah. I hope I didn't take too much magnesia. Let's see what happens. So for the second glove, we need yeast. Again, I want the reaction to start when the glove is closed, so I put the yeast into the thumb. Can even close it a little bit. And then I'll pour in the 10% hydrogen peroxide into the fingers. And then I close everything again. And shake it. This one goes faster. Already gets hot. Starting to react. Yeah, this one is pretty hot already. Like pretty, really hot. This one is hot too. Yeah, pretty hot. Oh my God, this is so hot that it burned through the glove. Let's hope it's still okay. We may have to make another one. And in the last one, I put in the baking powder. Oops. I put in the baking powder. I didn't open it. Yeah, nothing is toxic. The baking powder is toxic, so I can touch it. And I'll add some citric acid. And the reaction doesn't start until I add some water. So I'll add some water into the thumb again. Close it. And then shake it again. Oops. So the other ones, this one looks good. This I have to make again. And this one also seems good. But contrary to the first two, which got pretty hot, this one even turns cold. So you can see 3 different kinds of reactions. And the bromine is gone. So we can continue with the other reaction while I'll make the glove.
Okay. Martin, the messy one. For the Belousov-Zhabotinsky reaction, we add 2 milliliters of ferrine. It's a red solution with an iron compound. See, in the beginning it's red, and then the solution turns blue. And to see the pattern, we pour the solution into a petri dish and have to wait a little bit. Until the pattern is formed. In the beginning, the Belousov-Zhabotinsky reaction has 2 processes, which are first is process A, when the bromide concentration is high. A lot in the different steps, the bromide concentration sinks, falls, and then process B takes over. In this process, the bromide concentration gets higher because of different reactions, and when the bromide concentration is high enough, the ferrine gets oxidized and it turns blue. When the reaction, when the other process takes over, the ferrine gets reduced again and turns red again. Because of these different processes, there are circles forming in the solution. Blue circles on red ground, we can see. You can see bubbles. This is because carbon dioxide is forming in the reactions.
So I made the first glove again, already reacting, and I got my other tools. So hot, and the cold one. Another question is, what kind of gases did I made in these gloves? Is it just air, or did some certain kind of gas form? And for that, I'm gonna make a test. Oh my God, this is pretty hot again. I hope it doesn't burn again. So for this test, I need two things. The first thing is I need a beaker filled with water. And the second thing I need is a test tube. So now I'll pour some water into the test tube. Till it's filled to the brim, till it's completely full. Then I close it and then I insert it into the beaker. As you can see now, the whole test tube is filled with water. There's no air inside. And what I do now is I'm gonna take the hot one first, just to be on the safe side that it doesn't pop again. I'll take a syringe with a hole needle, with a cannula, and then I'll insert that cannula into the finger of the glove. And then I can pour out a volume of gas. And when I pull out the cannula again, the glove closes itself again like a septum. And now I can take this gas and fill it into the test tube. As you can see, the test tube fills with gas. Oops, if I don't miss it. So now the whole test tube is filled with the gas from inside the balloon, from inside the glove. Now I use the holder to hold it down. And how do I now test this gas? For that, I'm going to use a blowtorch. But I'm not going to use the blowtorch on the gas, but I'm going to use the blowtorch to ignite a stick of wood. Now you can see the wood is burning, and when I shake it a bit, it stops to burn, but you can still see it smithering. And now what I do is I take this gas and try to put in this stick and see what happens. Shake me a bit. And nothing happens. Nothing happens. Oh my God, it didn't work. What? Let's try it again. That's the charm of the live stream. Chemistry sometimes doesn't work as good as it should. So I'm gonna try it again. So first, I'm going to take out the gas. Then I fill it into the tube. And then I'm going to put in the stick. Okay, what you heard was a little sound. That sound was the gas inside the test tube burning. The gas itself doesn't burn without oxygen, but when I get out of the water, oxygen goes inside, and when I then add some fire, then it burns down. The gas inside this glove is hydrogen. So now let's test the second glove. So I put in the second gas into the test tube. Till it's completely full. Then turn it down a bit. And then I'll add it into the tube. And let's see what happens. And you see the tube starts to burn. Whoa, starts to burn more. There was still hydrogen inside apparently. And more. See it? So you saw that wood started burning better. And the reason for that is that there was pure oxygen in the second glove. Oxygen is the stuff needed for flames to burn. In air, we have around 20% oxygen, but with pure oxygen, flames burn brighter, and that's what you just saw. So I hope now you're curious what will be in the third glove, what will happen with the third glove. This one's dirty already. The new test tube. Let's play the game again. Add water. Put it into the beaker. No air inside, almost no air inside. Then add the gas. And then use the wooden stick. This time, to show it better, I let the stick burn a little bit so that you can see better what's happening. So I'll take the burning stick and put it into the vial, and you will see the wooden stick stop burning immediately. I'll do it again. Put it in, and you see it stops burning immediately. So different to the other two experiments, in the third glove, there is carbon dioxide. So this is one test to determine or to show what kind of gases are inside the glove. For carbon dioxide, you could also see a pH decrease when you put into water or you could add it into calcium hydroxide to see calcium carbonate forming. But because we have a cooler stuff to do now, we won't show that experiment. The question is now, because we want to know what happens if we mix these gases. And for that, I'm going to remove the third one. We just need the first two ones, the one with hydrogen and the one with oxygen. Going to remove the water and the test tube. And now I'm going to use this glass, which is filled with soap water. And I'm going to show you something, what happens when I just take hydrogen and put it into the soap water. You see bubbles forming. And what I can do now is I can let those bubbles, I can take fire and see what happens when I go the fire to the bubbles. Let's remove this a little bit. And you saw a small flame. Let's try it again with a little bit more. Yeah, you saw a small flame. What happens when I take oxygen? Put it in. And add the flame. And you almost see nothing. If you look closely, like if it looks like that, and I add the oxygen, then you will see it's burning it. You will see it burning a little brighter. But I couldn't be imagining that. But now the really funny thing is what happens when I mix hydrogen and oxygen. Just take a little bit of each, pour it in, and then burn it. So, ready? And now you heard a bang. The funny thing about that bang is I didn't take the ideal mixture. This bang was not loud yet. Now I'm going to take the ideal mixture of how to burn hydrogen and oxygen. You guys ready? Ready? Yes, this was the ideal mixture, just 9 milliliter in total, not much. If we use the whole two balloons together, I think we would destroy the hood. So let's not do that. But what you saw now was the so-called Nile gas reaction in German, which is called the same in English. So, and that's that. So, this was it for my reaction. You can now continue watching the oscillating reaction, and if there are any questions, you can ask us in the next few minutes in the live feed, and we will answer. Thank you very much.
Thank you for watching.
Thank you for watching, and till next time, maybe. So since there are no more questions and the oscillating reaction is almost finished, I'm going to show you what happens when you burn these gloves now. Let's start with the least funny one. Let's start with the one with carbon dioxide inside. So if I now put here the lighter, put it in a flame, you will see that the glove just breaks, but it doesn't burn because the carbon dioxide quenches the flame instantly. Carbon dioxide cannot be used like oxygen to full flame, so the flame dies down immediately. Then let's take the oxygen one. Was it the oxygen one? I'm not sure anymore. I think that was the oxygen one. So what happens if I try to burn the oxygen one? I'm not using any gloves. Don't use gloves while working with open fires. So I burn this one. And you see a really beautiful burning of the glove because the flame is really beautiful because it gets but when the oxygen is gone, the flame stops being that funny. So yeah, and you shouldn't burn plastic, so I stop burning. And now for the most funny part. What happens with the glove with hydrogen? Yeah, this one is a little bit dangerous, but you don't see my face, so it's okay. So what happens if I burn this one? Why didn't Felix Baumgartner jump from a balloon filled with hydrogen? We will find that out now. And oh yeah, that was the oxygen. So the oxygen, you see the flame burning more brightly. Or it blows even out the flame. You could see the flame burning a little bit brighter, but nothing else happens. The glove before had the hydrogen inside. So what you saw was that the hydrogen just burned in the air. So that's it for today. Thanks again, and maybe see you next time.